Hey Nuke physics fans, welcome to Block 5. So to start Block 5 off with, the first problem we're going to look at as an example problem for what we need to understand for this is TP10-35. So going through our problem solving process, we have the read step. We identify the half-life of strontium as 9.70 hours. This tells us that we're looking at nuclear energy and how we handle nuclear radiation in the termination calculations. So the task we're first given, find our decay constant. It's going to be 3 significant figures with our final units as per seconds. Our second part of the problem is the activity at 15 hours. Again, 3 significant figures with our final units of becquerel. The physics, as we mentioned earlier, is nuke. Nothing needed for the draw step. The givens, initially we're given the half-life, the time that we're trying to determine the activity for the sample, the mass of the sample, the mass of strontium, and the assumptions, none. Moving on to the solve step. From our PRC, we know that the decay constant is equal to the natural log of 2 over our half-life. We take that calculation and we get very simply 1.99 times 10 to the negative 5 per seconds. Note we've calculated per seconds going from the original numbers of hours based. This lambda is highlighted in pink because we're going to need that as we go through the equation. For part 2, we're trying to determine the activity of a 1 gram sample after 15 hours. So to do so, first we need to get the initial sample size. The initial sample size for nuclides is going to be equal to the number divided by the mass of strontium times the mass of the initial sample. This gives us the ability to carry it down to calculate the activity of those number of nuclides, where you take the number of nuclides times the decay constant, again pulling from part A, to get our initial activity. Once we get that initial activity, we plug it into our decay equation, where we get the initial activity times the exponential of the decay constant times time, which gives us a final answer of 4.51 times 10 to the 16th becquerel. Doing a real quick significant figures check, we have 1.99, which is 3 sig figs, 4.51, which is also 3 sig figs. We've already checked our units, and the answer is reasonable for nuclear questions. If you have any further questions, feel free to ask your instructor and review the solutions online.